Welcome to the new session, that is Introduction to Additive Manufacturing. Till now what we have studied is we were able to know about AM evolution, distinction between AM and CNC machine, and advantages of additive manufacturing and disadvantages of additive manufacturing. In this new session we are going to know about the AM process chain and steps involved in this AM process chain, right from conceptualization till post-processing, how it is going to evolve or how it is going to take place. Then we are going to know about the different classification of additive manufacturing process. So there are 4 classifications. They are liquid polymer system, discrete particle system, molten material systems, and solid sheet system. In this session we'll know about the liquid polymer system, what it is, and in detail we'll be knowing about the SLA technique, or we call it as a stereolithography apparatus. AM process chain, or also called as additive manufacturing process chain. As we know, additive manufacturing involves number of steps. All these machines which are using additive manufacturing as a technology follow these steps. So they move from a virtual CAD description to a physical resultant part. Here is a flow chart of the process chain. The first step is the CAD. So any of the CAD platform or CAD softwares are having this flexibility of preparing the CAD model. Under the CAD model we can prepare the desired concept, and that concept can be made it into a 3D part. So need here is to convert that one into a 3D object. After that, in the same CAD platform we are having the file conversion, that is converting the CAD file into a STL conversion. So that one we call it as a stereolithography conversion. Then the file has to be transferred from the CAD to the machine. So where machine is going to develop the product. So file has to be transferred to the machine. That we call it as a file transfer. In the machine we have to do the initial setup, like a start point or the cycle time, the material feed rate or the layer build-up rate, and other parameters which are needed for the product to get developed. So those are made in this step, that is machine's setup. Next, building of the material takes place on the platform of the machine, where the build is happening on a layer by layer basis. After the build is complete, we have to remove the material from the build platform. So removing of the material or any additional supportive material are also there, that also get removed. Then post processing, finishing operation or removing of unwanted support materials from the product developed, that one we do it in a post processing, or giving it fine aesthetic look, polishing or a painting is done in a post processing. Last one is application, using of the product which has got developed onto from a additive manufacturing machine or following this process. So here is a pictorial representation of how a CAD model of a coffee mug has been drawn using a CAD software. So you can use AutoCAD, CATIA, Unigraphic, any of these softwares and prepare a 3D CAD model. Then we need to convert it into a STL file, that is stereolithography conversion. So the model is getting divided into different layers. So it is division of the layers into grids and nodes happening. Then here we can see the file is getting transferred to the machine, and machine has made the initial setup where the product is going to get built and what are the positions for this one. Next we see the machine setup happening here with telling which layer is getting deposited, what rate and what are the position, and how much time it will take for the build or remaining time for completion of the product. Then fifth one, building process starts. So one after the another layer is getting built, and here the product gets completed after the build process is over. Then we need to remove the product from the build plate. So removal of the material or a product from the build plate happens in the sixth step. As it gets adhere or sticks to the surface, from the surface you have to remove it. Next comes the post processing. Under post processing, the finishing or surface cleaning or support removal or sacrificial layer removal is taking place, and if we require to apply paint and give aesthetic look, that happens in case of post processing. Last one is the application, and you are using the product for the end to how it has got formed or how it is going to be coming out. That is also one of the step in case of additive manufacturing process chain. Here we will go in detail with the additive manufacturing process chain. The first step is creating a CAD model. All additive manufacturing parts must start from a software model which fully describes the external geometry. This can involve use of almost any professional CAD solid modeling software such as AutoCAD, CATIA, ProE, Unigraphics. But most important thing is they have to be in a 3D solid or should have a surface representation into it. After that, the next step is to converting that 3D CAD model into a STL file. So a machine accepts only the STL format file itself only. STL means stereolithography file. So moreover, this has become a standard, and nearly every CAD system can give an output of such a file or in this file format. This file describes the external closed surfaces of the original CAD model and forms the basic for calculating the requirement for slicing. Here is a pictorial representation of the coffee mug which is done on a CAD model, that is on a CATIA. Here next it is converted into meshes. So here we can find a different mesh. So here there is a triangular type of meshing taking place, and each layers are getting sliced here. So you can see the slicing of the layers of this coffee mug, and there are number of nodes which are getting connected with the elements here. So this is needed for the machine setup for building or producing the orientation for machine building or tool movement. Okay. Next, transferring of the STL file into the AM machine. The STL file will be having the description of what part must be transferred and to the machine. Here some manipulation work may be required, so for getting the correct size and where to position and how to have the orientation. For example, this is the CAD file of a sphere. So in the STL file or in this machine transfer, we have to tell about how to orient it, means from where to build, either from this bottom to top or top to bottom. So orientation, correct size, and what should be the tool movement and how much tool movement, all those things comes under this step. Next one is step 4, that is machine setup. The machine must properly set up prior to building process. Before building, it has to be having all the parameters ready, like whether it is having sufficient material or not, or in the machine setup whether there are any material constraint, means tool movement constraints, so that it can build or not able to build. For example, in this one, the tool has to move from bottom to top. Okay, so it is to it has to get the how much material is sufficient for this one or not. Then energy source of energy here, it may be an extruder like this, it may be extruder, or it may be a laser also, which may be the source, and selection of source. Next one is the layer thickness. How much should be the layer thickness for building the product? So you can see the layer thickness here. So whether this layer thickness is sufficient, and time to complete the product. How much time it will take to complete the whole product? So the product gets completed within minutes or it will take hours. So those all things are going to come in the machine setup. Next comes the building. So building part is mainly a automated part. So AM process part comes in a building. So machine can largely carry out this work without any supervision. So machine will be already having the position where to start. It is, if it is starting here, so it has to end at the top, that we know, and machine knows how much feed is to be given and how much material it is going to come. Only partially some superficial monitoring of the machine needs to be taken place by the operator, so that there are no errors taking place, like errors in the sense we call it as a run out of material, means material get exhausted, or a power failure, or some software glitches or technical faults which may occur during the building process. For that we require supervision. Then later we will be getting the final object. The final object has to be removed once the AM machine has completed the build. The part must be removed. So there may be some interlocks or interaction of the machine with those interlocks, so that has to be ensured that it is removed, or any operating temperature which was occurred, that has to be lowered and then it has to be removed. Otherwise what will happen, distortion of the material may take place when it is getting exposed to the ambient temperature. So that care has to be taken care while removing. Next we are having the post processing. Once removed from the machine, the part may require additional cleaning, means here we are having the supports for the part which has been built. So these are the sacrificial or scaffolds or supporting materials which are built along with the part. So these has to be removed. These parts are little weak, like they are like our thermocol. So if we just apply some amount of force, they get removed. So therefore it requires certain time and experienced people, so that or experienced person can remove them very easily, because they know which is the parent build material and which are the supporting material. So here little bit of manual manipulation or manual intervention happens with the post processing. Next comes the application. The parts now when they are ready to be used, however, they are required to have certain additional treatments like a heat treatment or sand blasting or removing of burr or surface finishing, for which helps giving good aesthetic look and it will be acceptable by the consumer or by the customers, like applying a primer so that it doesn't rust or it doesn't corrode, and giving painting or applying paint so that it is acceptable with a good texture and finish. In totality, if we tell for any additive manufacturing technique, if you go, we see all this process happening. So same process chain is followed in almost all additive manufacturing machines or techniques. Classification of AM process. There are numerous ways in which additive manufacturing technologies has been classified. Under the literature, we can see firm used 4 separate material classification, that is liquid polymer, discrete particles, molten material and laminated sheets. In this, he used 2-dimensional classification method. The first dimension relates to methods by which the layers are constructed, and the second dimension raw materials to the classification. So here we can see the liquid polymer classification. In that, in the first dimension channel, the SLA developed by 3D system. SLA means stereo lithography. So in this, a single beam is solidifying the exposed polymer and it makes the 3D part by layer. In the dual beam SLA developed by 3D systems, you can see 2 beams simultaneously solidifying the exposed polymer. The object company, they developed this technique in which array of beams are solidifying the polymer part. So here it is also getting built here. And the Envision technique, in this developed by Microtech, in this we can see a 2-dimensional channel which is solidifying the exposed polymer. Similarly, in a liquid polymers, these are getting exposed to the laser in this different manner and making the product solidified or coming out a solid 3D part. Under the discrete particles, here instead of using polymer, we use the powder, so separate powders. So the method used here is SLS. SLS means selective laser sintering, means selected area gets exposed to laser and solidifies. So developed by 3D systems, EOS, Lens, SDM. So here these companies use the 1-dimensional channel of making the 3D parts. Then we are having the LST, which was developed by EOS. They use 2x1 dimensional channel method of product development. Then 3D printers, they use, or 3D printing company, they use the array of 1-dimensional channels where the powder particles are getting exposed to an array of beams. So these beams solidifies the powder particle. Then DPS, this uses the 2D channel and prepares the product which are getting exposed. So in a one go we get a material which is solid like this. Then comes the molten material. Here the material is fed. The molten material is fed through the extruder and it gets deposited line by line on a layer by layer basis. This is used in FDM technique. And similarly, in a thermojet machine, we see a beam of extruders are in a line or in an array, and they are extruding all the materials simultaneously, like our dot matrix printer. So they jet all the extruded material onto the surface, and the build is happening simultaneously. Then comes the solid sheets. The solid sheets, here the sheet wherever has to be built, that is exposed with the help of a beam, so that cuts out and remaining part is getting solidified. So this is developed by a Solido and PLT. The company which develops this one is Canara. So to tell you more, there are 7 families of additive manufacturing according to ASTM F2792 standards. Here you can see the first one is the wet polymerization technique. Under this we are having different names for this one, like SLA, DLP, 3SP, clip. So popularly we have the SLA, that is stereolithography apparatus, and typical materials we use is photo curable resins or photopolymer resins, which are getting cured by ultraviolet. Next we are having the powder bed fusion, which we call it as a PBF. Alternative names for this one is SLS, that is selective laser sintering, or direct metal laser sintering. So we are having the these types of techniques where electron beam are going to help in melting the powder and getting a fusion of the powder materials. So here typically materials prepared are based on plastic, metallic, ceramic powders and sand. Next one we are having the binder jet technique. So for this one I called recently the name, that is 3D printing, 3DP. So these are the technique which here liquid bonding agent are selectively applied, and the bonding will take place between the powder and the liquid. So typically powder, the plastic, metallic, ceramic and glass and sand are used. Next one is the material jetting. The companies which prepare this one are the Polyjet and the Multijet Modeling or Project we call. These are the companies which make this one. So droplet of material are deposited layer by layer. So the material itself only is deposited layer by layer, and a product gets bounded when it is exposed to ultraviolet or any curable heat source, whatever we provide. So these are typical for materials which are photopolymeric and polymers and waxes. Next comes the sheet laminates, or we call it as a long process laminated object manufacturing. There are a selective deposition lamination also. Here the sheets are getting stacked and laminated together to form an object. So typically paper, plastic sheets or metal foils, tapes, these are used. Next one is the material extrusion, that is fused filament fabrication or fused deposition modeling we call it as. The material is extruded through a nozzle, and through an orifice it's going through, and then it is going to get a track on which it has to deposit, and it is going to get glued to the surface, and it is going to build one layer on the above. Typical materials are the thermoplastic filaments and pellets and liquids and slurries. Next one is the direct energy deposition, or we call it as also has the lens, that is laser engineered net shaping or LMD, laser material deposition. So a powder or wire is fed into a metal pool which has been generated on the surface of the part, which is it has to adhere. So here mainly metallic wire, or here we use the powders which are going to get deposited on the area which has to be fabricated. Ceramics are also used. Mainly these are used in tool product designing. Okay. Next one is the alternative method, that is the hybrid method created by hybrid manufacturing technologies. So here laser metal deposition form of a DED is combined with a CNC machine, which allows additive manufacturing and subtractive manufacturing to be performed in a single machine, so that parts can utilize the strength of both the process. Typically metal, powder and wire with ceramics are used. So these are mainly to give additional information how the additive manufacturing has been divided into 7 families. Let's go in detail and understand the various classification of additive manufacturing process. Firstly, the liquid polymer system. Liquid polymers appears to be a popular material in additive manufacturing. The first commercial system was the 3D systems, which was called as a stereolithography process or stereolithography apparatus. It was based on liquid photopolymers. Let's know what is lithography. So as we see here in this diagram, there is a stone on which we are having engraves or the negative generated here. So the printer has made some engraves here, and on these engraves we are going to sprinkle some printable material like graphite, powder or colorable agent on this one. Then this sheet of paper is going to be placed on this one, and later we are going to roll this one on the table. After certain time we can see the negative getting converted into positive, means here we get the print. This is the print of whatever has to be printed. So this technique which we have been doing with our carbon copies also, or in childhood days on engraved surfaces, keeping a sheet of paper and then applying a pencil, and we get the image of that engraved part of a coin we used to do. So this one we call it as a lithography. Hence the term lithography was first introduced in 1986 by Charles W. Hull. He was the one who defined that it is a method of photopolymerization of a liquid monomer resin by fabricating solid parts. Let's know the principle of a stereolithography. Here a vat of a liquid photopolymer resin is cured through a selective exposure to light. The source of heat here is either light in the form of a laser or a projector, which then initiates polymerization, which converts the exposed area into a solid part. Means wherever there is an exposure of this laser on this photopolymer resin, it gets solidified. Moreover, the photopolymer resin is applied here layer by layer, and then ultraviolet light hardens the resin to create a final part or a object. So when the light is going to fall on the photopolymer resin, it is going to harden it. Let's understand the stereolithography process with knowing its past parts. So in a stereolithography apparatus, firstly we have the container. So the container is having a liquid polymer which is a photosensitive resin. So it is filled till the brim here. Then we are having the laser. So this is a laser unit which scans the photosensitive resin in a X and Y position. So wherever it is exposing, so that particular part gets hardened, and the part is built on a platform. The platform is connected with the elevator. The elevator is powered with the help of a lead screw for elevation in Z-axis. Wherever the laser beam is getting scanned or getting exposed to the photopolymer resin, the part is getting built. The built part will be in a layer by layer form. So initially the platform is at the top. As the build is continued, the platform descends and the complete part is going to be immersed inside the vat resin. Let's try to understand in detail the working principle or working of a stereolithography process. So here is a schematic diagram or representation of a stereolithography apparatus, that is SLA. As we know, SLA is a laser based rapid prototyping process where it uses a CAD file which is in a STL format. So from the STL format we transfer that file into the machine where it is going to convert into a product. So mainly it uses the ultraviolet radiation for hardening the photosensitive resins. In this technique, the building of 3D models will be from the liquid resin, that is the photosensitive polymer, when it is getting exposed to ultraviolet radiation. Here the source is the laser which is needed for the chemical reaction. That one we call it as a curing, where bonding of large number of small molecules to form into a highly cross-linked polymers. Here we can see the polymer getting solidified, a support structure getting created on the platform. As we know, the need here is for a ultraviolet light. So the ultraviolet light comes from the source, that is a laser source, which is controlled by the scan mechanism to have a raster scanning and to expose the laser to where it has to get solidified. And the laser is going to penetrate into the resin for a very short duration or a short distance. So the distance required for the thickness or how much layer thickness we require, for that much distance only it is going to get penetrated. The first layer is bonded to the platform here, which is placed just below the surface of the resin container. So the platform gets lower one layer at a time based on the thickness, and scanning is performed for the next layer. This process will continue until the part has been completed. This is how a stereolithography apparatus works. Let's understand some of the advantages and disadvantages, merits and demerits of a stereolithography process. Under the stereolithography apparatus or a process, we will know firstly the advantages of this process. The first very most important advantage of this process is it can be operated round the clock. Means SLA can be used continuously and unattended round the clock. Here a skilled operator may be required first to initially make the machine setup and start the machine, then it need not worry about the operations. It can take care by itself. Good user support, as I have told you, so here it is a computerized process, and because of computerization it provides good user support, means user friendly type of a machine. Hence input of the machine and output for the machine are very convenient. Next, build volumes. Different SLA machines have build volumes ranging from small to large volumes to suit the needs of different users. So some users may prefer to have small volume products for R&D or for some research based type of product. Some people may require large volume or a larger products which may be used directly into the application. To cater the needs of the customers, build volumes can also be varied. Good accuracy. It has good accuracy, thus it can be used for many applications. Quite a numerous applications are being using the products which are being developed by stereolithography process. Surface finish. The SLA can obtain one of the best surface finish among its class. So in different additive manufacturing process products, when we compare, so we find that surface finish obtained from SLA are quite acceptable. Wide range of materials. So it provides a good advantage in applications or usage of materials. So materials from general purpose materials to specialty materials for some specific applications are also being used in SLA process. So hence these are some of the advantages of SLA process. Now we need to know the disadvantages of this process, that is stereolithography process. So the main disadvantage here in case of a stereolithography process is the requirement of support structure. So structures that are having overhangs, we have seen that whenever there are structures which are having overhangs or undercuts, that must have a supports which need to be designed and fabricated with the main structure also, because the material or the product which is developed in the liquid resin. So there is only one single resin. Using the same resin itself only the support structures have to be done. Hence the designer has to give emphasis, or he has to take care about fabricating the support structures using the available material itself only. Next important or major disadvantage here is requirement of post processing. Here post processing mainly includes removal of the above, that is the support structure, and unwanted materials or any sacrificial layers are there, those to be removed. So which is a time consuming or a tedious job and can even damage the model if it is not properly removed. So for that, skilled operator or a skilled person are required to identify which are the support structure, which are the unwanted materials, and which are not going to cause any damage to the model. So those materials only has to be removed. For that reason, precautionary measures or some caution has to be taken. Lastly, we find that requirement of post curing. Post curing may be needed to cure the object completely to ensure that integrating of a structure. So curing of the material or a product is required for after post processing, like we can have the sand blasting or we can have a heat treatment, or we can have some surface finishing, or we can also have some priming or enamel work, means painting the product for giving a good aesthetic look. Because from the product whatever we are going to get, these features may not be added into the product during the manufacturing. That is one of the disadvantage of this process. Next, application of SLA process products. So I have seen that SLA is having quite a good advantages. Hence, the SLA technology provides methods for reducing time to market, therefore lowering product development cost, which gains greater control for their design process and is improving the product design. Mainly as a designer, what we require, we have to present it properly. Hence, SLA models for conceptualization are helping in giving elaborate concepts in a smaller and a neat, with having better presentation qualities, with giving packaging also. A total packaging can be provided with the models which are presented with the help of a SLA. SLA are also used by the design engineers for preparing prototypes, where analysis of these prototypes, verification and functional testing can be done. SLA parts are used for prototype tooling, and where we require low volume production of tools. Means in a small setup where we require limited tools, not many tools, there we can have this SLA machine where we can bring new prototype tool and use that tool for production and checking whether it is viable or not. Under investment casting, sand casting and molding, SLA products or SLA processed products are finding much of its applications nowadays. SLA are also used for tools for fixtures and tool design and production of tooling. Like this, we can see that stereolithography processed products are finding much applications in case of tool design, investment casting, prototyping, presentations of prototypes, and in lowering the overall product cost. Thank you. You can contact me at naveen.kalal@canaraengineering.in.